Can someone get on YouTube and check that indeed I am streaming and that you can see it and that the sound is okay? Um, okay. I should have waited on this one. No, you can't see the screen? Nothing? Hello, hello. On my side of it, it looks like it's working. Yeah? Yeah, can you see? Sound is okay as well? All right. Could someone send a message via that, via the little sidebar? Okay, yeah, great. Thank you so much. I appreciate it. All right, welcome back. We're in Engineering 11. This is Wednesday of week 3. We're in class 6. Today we're going to be working on lesson 2. I am supposing that some of you have generated questions while you were working through the content. If you'd like to ask those now, you can raise your hand and I can field them. The other way you could do is actually literally copy and paste questions that you had from over the weekend into the chat forum on our live stream chat option from YouTube. And then I can kind of read those as we go along. We did have one announcement, which we'll talk about again later today, which was that we extended the due date from Lab 2. Instead of Lab 2 being due today, it won't be due till this coming week on Monday. That was a gift from your fellow students. I don't remember who brought that to our attention, but whoever it was, I really appreciate it. And then I actually have some feedback to address your question. I didn't get to make those videos, but I actually brought the examples with me. And during the lab session today, I plan to show some examples and then address any questions or concerns that you might have. So it's been on my mind, even though I failed to address that. Thank you so much for that question. Let me pause for a moment and then ask for questions and concerns. I'll shut up for maybe 15 seconds and let it get real awkward. Brought to us by YouTube. Let's go ahead and, in that case, if you do have questions, feel free to surface them as they come. I have a question for you all. What does MATLAB stand for? Matrix Laboratory. And do you know the person's name who built it? Cleve Moeller, a guy named Cleve Moeller. The entire idea of MATLAB is that it's what we call a vectorized language. And what I mean by that is that all MATLAB variables, numerical variables, are stored as arrays. So for example, if I create the variable a equal 5 or 4 and suppress this, this thing is stored as a double, but what we mean by that, so if we go back up here and we actually say the size of it, notice that this is actually a 1-by-1 matrix, which always makes me laugh, right? A 1-by-1 matrix is otherwise known as a scalar, but what that means is that in MATLAB's memory system, when we're storing numerical variables, MATLAB interprets everything as either a vector, which is either a single column or single row, or more generally a matrix, right? And that's why if I, for those of you that took my linear algebra class, or any linear algebra class, mine's the ones that use the MATLAB notation. So I might ask Nick on this one. When I say A4, 6, what do I mean there? Yep, fourth row, sixth column, that the value is 5. Could you guess what MATLAB will immediately do when I enter this command? Jean has it. Yeah, it's going to create a matrix that has 4 rows and 6 columns. The entry 4, 6 will be, and everything else will be 0. And that's exactly what happens. So today we're going to go much, much deeper into the concept of arrays. I don't know if I should write stuff down. I hope you'll be proud of me. I'm proud of me today. Some of you said that I should, Art is not here at the moment, but Art gave me an assignment last week, which was to get my my computer so that I could capture, sorry. There it is. Oh yeah, so that I could capture writing. So in MATLAB, the voices in my head just won't leave me alone right now. We will create 2 types of what we're going to call arrays. When you see array, you could think about organized numerical data stored in memory. I'm going to kind of pick on Nick because I think he's the only, and Misha too. Those are the only 2 folks, I believe, in this classroom that took my 2B class. Is that right? Raise your hand real quick if you did take Math 2B linear algebra. Okay, I might also kindly encourage coordination here. I teach my linear algebra class with MATLAB in mind. I don't know that other teachers are that silly and crazy. Do you remember what we called the operative data structures in Math 2B? What the main thing we studied in all of Math 2B were? There's 2 types. One of them starts with a V, and the other one starts with an M. Yeah, vectors and matrices. So I might say, in this case, we're going to think about vectors and matrices as the mathematical terminology. And then when we store them in data, we'll call those things arrays. Just as a quick recall, maybe we'll do a visual. The set of all vectors is a subset of the set of all what? Matrices. All vectors are matrices, but what? Not all matrices are vectors, right? Yeah, everybody that lives in California lives in the United States, but not all people that live in the United States live in California. That's a very classical logical structure. So let me ask you this. We're thinking about 2 types of arrays. Could you guess what type 1 is? Yeah, so in math, we're going to think about these things as vectors. You're going to see that I try to kind of toe the line between math and coding. We'll think about these as what we call one-dimensional arrays, and maybe we should get our real nerdy voice on. These are one-dimensional arrays that are computer representations of mathematical vectors. The hell did I just say? Thank you. I got like 5 smiles, and I think you were laughing at me, not with me, right? I hope so. Ooh, yeah. I hate the definition of a vector as magnitude and direction. I detest it with all of my mind, right? Misha, do you remember what I like much better? Yeah. Damn, Misha. Just carriers of information that are organized in special ways. So it is true that we can impose geometric meaning onto vectors. I don't do that to standard. So the way that I think about all vectors are lists of numbers organized in either a If you tell me that you're going to do physical applications, then I'll say let's think about it as a magnitude and a direction, because magnitude and directions exist in three-dimensional space and in time, right? Yeah, so we'll talk more about that. Yep. If you want to know about my oddities teaching that class, you can speak with these guys. I got my PhD in numerical linear algebra. I could have spent my whole life researching, but I felt like that would be a little bit selfish. So instead, I want to change education around this particular topic. It's why I came to Foothill, actually. So I have a lot more to say about that subject. Okay, so one type of array is going to be one-dimensional array. Can you guess what the other type of array might be? Yeah, go ahead. Two-dimensional arrays. And what is the mathematical concept behind two-dimensional arrays? Yeah, arrays of arrays. Another way to say that is matrices. Yep, you got it, Michelle. Matrices. So let me write this and then we'll go on. MATLAB and indeed FPUs. Do you know what an FPU is? It's a floating point unit. So the brain of this computer is a microprocessor. The microprocessor has many different sub-circuits on it, one of them which is an ALU, an arithmetic logic unit. One of them is FPU, floating point unit. One of them is a control situation, right? It's the different sub-circuits that break up the brain. One of the things that you may not be aware of, but is definitely true, is over the last 50 years, we have put billions of dollars to optimizing our brains in our computers to do vectorized math very, very quickly. So in 1950, when the ENIAC was built, was the first computer ever built. It was used for shockwave calculations in the design of atomic bombs and also not solving nonlinear trajectory problems. So when you're on a boat and you want to sink a German U-boat, instead of people doing that by hand, you could put it into a computer, fire the shell, sink the Germans, right? It was amazing, in fact, world class, if you could solve a 20 by 20 linear systems problem. So 20 variables, matrix. So let me just say this real quick. So for those of you that took my class, this is not going to be unfamiliar. So do you remember this matrix structure if you took Math 2B? So I'm looking for the solution of a matrix vector multiplication problem. I know the output, I know the matrix, and I want to know the vector. In the 1950s, this would have taken days of computational time, and you would be world famous. In fact, people were world famous when they could solve this. Because prior to that thing, people would do this by hand, and literally you'd be up a creek without a paddle, right? Today, there are, like the Google matrix is quite amazing. Do you all know what PageRank is? You ever type in a query at Google and then the top one is usually really, really good? That's because the top result has the highest PageRank. PageRanks are numerical numbers associated with the what you might call appropriateness of each web page. Google sends out what they call spiders out the entire web. The spiders document every website that's ever been created, and then they create something called a Google matrix. The Google matrix, the number of websites that exist in the world that Google has touched is on the columns, the same number of websites in the rows. It's actually a Markov matrix, which I'll have a lot more to say about. The entries are the number of links to and from individual websites. That is actually now an eigenvalue problem. It's a very, very famous eigenvalue problem that Google translates into a linear systems problem. Let me repeat that. When Google produces top results, they solve a problem that looks like this. The matrix in that problem has billions of entries, and they do this about once a month. Have you ever noticed that in month 1, you get different results on Google than in month 2? Yeah. Google does two things. Number one, it is constantly searching, sending out spiders in the entire web. So it redocuments the entire web in very, very smart ways, at least I mean, every second of the day, there's thousands and thousands and thousands of servers dedicated to that. And then it will recalculate the solution to the linear systems problem to produce what they call the dominant eigenvector of the corresponding Markov problem. Don't worry about any of this. I'm just cussing, right? The point of this is Google's entire technology depends on the ability to solve this problem. They have some of the best scientists in the world designing hardware to do that well. I would not be surprised if a world-class team of electrical engineers designed a supercomputer just to solve this linear system problem. Now, you don't have to know any of this, but prior to your existence into this class, from the 1950s all the way to today, do you know what an entire multi-billion-dollar industry, you might even say trillion-dollar industry, has been designed to do? Implement vectorized code on computers. Say that back to me. Okay, so in other words, use computers to do linear algebra. Say that back to me. Yeah, I mean, not the same words. AKA, when I say linear algebra is the love of my mathematical life, that's like saying oxygen is the love of my biological life. Right? MATLAB is a prototype language that allows you to do linear algebraic calculations quite quickly. It is not a general purpose programming language like C, Python. Those are general purposes, right? You can solve any problem under the sun. You can write the operating system for cars, like Tesla. You could write in, I think probably Tesla has its own, but you could write in C. Semáforos. ¿Cómo se dice semáforos en inglés? I forget right now. Stoplights. Stoplights, right? The control system for stoplights you could write in C. I would not suggest doing that stuff in MATLAB because MATLAB is not designed for that purpose. What is it designed to do? Work with numerical data in a vectorized format, aka do linear algebra quickly on computers. So the immediate challenge I would have to, how many math majors do I have in this room? Yeah, I can't wait. We're gonna, yeah, the longer I work with this guy, the more we're gonna get you deep into that. How many non-math majors do I have? Yeah, another one. Okay, so here's an immediate question for you. Why should linear algebra or math be involved in any science? I'm not going to answer that question today. And in fact, your lab 2, you start to try to get answers to that question for yourself, right? I have a lot to say about that subject. I'm not going to talk about it today. Today's introduction is going to focus on some of the fundamental numerical data structures called arrays in MATLAB. So I'd like to go back into that framework. Any questions pop up? I should probably check our YouTube site. Oh, cool. We have a friend following along at home who says video on FPUs from computer file. Yep. Can you upload? Can you upload that URL? So this guy is at home right now. Yeah, I would not call him a fool nor a matrix, but all right. Yeah, I guess one thing that we can do actually, I think this is useful. Let me go to OSB and then go over here. I'm not going to recapitulate all this. These are in your notes. So if you download the lesson plan for lesson 2, which we're on page 4 of that lesson, you're going to see some overview of what I call vectors. I think it is absolutely not very well designed that we do not require linear algebra as a prerequisite for this class. I know why we don't, but because we don't, I'm going to repeat some information for those of you that have not taken Math 2B. So when you see me, I'm going to encourage us to think about vectors in a very special way. So in particular, I'm going to say that in vectors, we're going to have 5 different ways to think about them. Number 1, what's the first type of thing we're going to do with vectors? Say it again. Yep, store data. The word vector, advector in Latin means carrier. You ever seen vector control trucks around the, yeah. Carriers of diseases are vectors, right? So if you control vectors, it means you get rid of carriers of diseases. Vectors in math carry numerical data. What's the next thing we're going to do? I mean, read it. I wrote it, so I know it. Combine data. What do you think combining data means from the standpoint of mathematics and computation? Addition, subtraction, multiplication. Division of vectors is kind of weird, but you could think about it, right? So some numerical operations on data.
Maybe like each value if you have a mass vector in a
Yep. Okay, what's the next one? Do you remember in Math 1C, how many of you have taken Math 1C? That if you had two vectors, you could take the dot product and start to understand how much one was in the direction of the other? Right? You could measure the parallelity between vectors. And you could also, in 3 dimensions, measure the perpendicularity using the cross product, right? So, in other words, you could use vectors to study the similarities and differences between quantities, right? Okay, what's the fourth way that we do this? This is really awkward. Measure length and distance. That's a much, that's not an easy thing to think about. What does it mean to measure the length of a vector? We'll talk more about that as we get deeper into the study of vectors. We may, I don't know, we'll see what we get to today. And then the last one is, yeah, so when we add, subtract, divide, multiply vectors and scalars and all this stuff, what are the properties that those follow? We're not going to go into a very, very deep study of that in this class because this is not linear algebra, this is MATLAB. But what I want to say is the first fundamental data class that we're going to look at in terms of numerical arrays is going to be what we call a column vector. So let me ask you this. Can you draw a column in the air for me with your right hand? Yep. So I had some people go like this. Okay, can you draw a row for me? Okay. So column vectors, if you say an n by 1, like a 5 by 1 column vector, can you guess how many scalars make up that vector? 5. So I'm going to stack 5 separate scalars, one on top of the other, into a single column. So column vectors have multiple rows, single column. In other words, they're one-dimensional, right? Because all the dimensions are stuck in one column. Does anybody else hear that? It's kind of annoying, isn't it? Do we know what it is? It's coming out on the inside. Maybe during break time today we can figure that out, or you can do it while I'm speaking. Say that again. Column vectors are organized into rows. What about row vectors? Stored in multiple columns. Okay, so let's go back to MATLAB. Okay, here we go. So let's create our first vector, and let's call that vector v1, and we'll create a 2 by 1 vector, so 2 rows and 1 column, each of whose entries are 0. So v1 is now stored as a 2 by 1 vector, each of whose entries are 0. Let's create another vector, which we'll call v2, and we'll store that -1, 1. Can someone tell me what that vector is? Is it a column or a row vector? How do you know that it's column? Delimited by the semicolon. Okay, watch this one. So we'll create a next one, and I'm going to do something fancy, and I want you to get mad at me, okay? Okay, so open brace, close brace, 2, 1. What would that vector be? Row vector. But when I hit it with the chunk, when I hit it with a little 10, turns into a column, and then I can store that column as the vector v3. right? So, in other words, we think about braces, the little square braces, as indicating vectors or matrices. If we want to create row vectors, we delimit each column with a comma. If we want to create column vectors, we delimit each row with a semicolon. Okay, so that's the major idea there. I have some data on how to do that. In order to store, of course, we always hit the enter button. Let's go ahead and take some data from what some people call global warming, what I call an existential threat to my son's livelihood. So we will take, so let me see if you can figure out this code. Stored as a, what type of vector? Row vector. Let's say that I wanted to start at 1990. Let's say that I wanted to start at 1990 and go by twos. Did it actually hit 1997 in that case? What if I wanted to start at 1993, go by ones, and store it instead of a row vector in a column vector? Yeah, 10, chong, and then suppress the output. So now if I check year, indeed I have that, right? And then why don't we do what we say average temperature deviation? And you can think about this. Anybody notice that the seasons matter?
Yes.
So if the year is a cosine function having to do with average temperatures, what would happen if the warmest temperature gets warmer in terms of the global yearly average? The deviation in temperature would increase. So if you noticed a trend over, I don't know, 200 years of data of increasing global temperatures in terms of the maximums and increasing deviations, what might you start asking yourself? Yeah, and this is exactly what climate scientists have been doing since the 1970s. I have a lot more to say about that whole ridiculous debate. But what I wanted to show you is we could actually capture some data. Someday we'll actually import this into MATLAB, so I'll give you an entire data set from the Keeling curve. So this is actually a subset of data from what we call the Keeling curve. And you could import all of that into MATLAB using the load functionality of MATLAB. What are they complaining about? Oh, there it is. Okay. And then you could do this thing. I mean, I kind of forget how to do plot. What if I wanted to plot the years versus deviations? Wonder where I would find that info. I literally don't remember how to plot because it's been a minute. I guess I could just click right up here, right?
First argument is the x-axis, second is the y-axis, and then what element,
Yep. So just type in the word plot. I wanted to show you this because I actually am thinking later in the course I'm going to give you a project and give you no guidance on how to do the project. So for the first 8 lessons, I'll give you a ton of guidance on how to write code. And then eventually what I'm going to do is just give you the project, give you no lessons on the syntax, and then you're going to have to figure that out for yourself. You can argue with me about that. I'm not set on that right now. You can like convince me that I need to give you syntax, but I'm literally thinking about that. So about week 9, I'm going to give you a pendulum project, not teach you how to graph, not teach you how to load stuff, and then you're just going to figure all that out on your own. So as we get closer to that, prepare your arguments. I can be convinced, right? But let's go ahead and check this out. Right now, what do I have stored in data? I have 2 vectors. I have the year vector and I have the average temperature deviation. Let's say that I wanted to plot one against the other, right? So let's go ahead. It looks like I could just do plot year. Oh, I broke my own rule. Plot year, average, and then if I push tab, Is average capitalized? Oh yeah, that was stupid. And then MATLAB is going to take its time producing the plot. Do you see something automatically that starts to give you some indication of how MATLAB, if I give MATLAB disparate data, what it does with that data? Linear interpolates. This is called the linear spline interpolation. I have a lot to say about linear spline interpolations. They end up actually producing diagonal matrices, which is really interesting. We'll talk about that at a different thing. Could you guess what one thing I might want to be able to do in MATLAB? Yeah, graph it as points rather than lines, right? So one of the things that I might ask myself in this whole thing is, how would I not have them interpret linearly? So one thing that I could do is get to a place where, oh, look at that. Control C.
I think the marker indices refers to
The next one.
what's after it.
Okay. Okay, so what did MATLAB just do?
Line and bar.
Yeah, so now the question is, well, how would I delete? I want to know, how can I delete the linear interpolation? So what would I do to figure that out? Keep reading. Right? I mean, I'm not going to do this right now. We don't have to go into this, but I just want to...
Line specification. Yeah, if you just leave the blank space. If you don't tell it how you want to format it at all, do a line. But if you start formatting it, if you do just a circle, no dash.
So if he's telling me... Ah, look at that.
I taught you something about MATLAB.
I mean, I to be honest with you, I've used this for years. I just don't remember at the moment. But I'll take it. You taught me something, I should pay you, right? Yeah. The point, though, is I could memorize syntax, and if I was using this every day, it's probably worth my time memorizing syntax, right? But if I really need to know how to do something, what's the only thing I need to do? Set aside some time to read. Right? Yeah, we'll talk more about that as we get further into this. Okay, so what have we done so far? We've started to graph row vectors and column vectors. Let's go ahead and revisit what we call the colon notation. Let me see if somebody can give me what you think this might be. What do you think that is? Okay, yeah, create an array that starts at 2, goes up to, ooh, I wonder. What's the upper bound in this case? Yeah, let's take a look. So 2 would be the first one. What would be next? 5. Ooh, 5 plus 3 is 8. Wait, I think we need MATLAB for that one, right? So 5 plus 3. Okay, woo! All right. So we got 2, 5, 8, 11. Okay, so let's go ahead and check. Or did I not? Is it going to be a column or a row vector? Yep. Okay, what would my ending input have to be if I wanted it to actually touch the output and be 4 by 1, for example, or 5 by 1, 1 by 5?
That's
11 plus 3 is 14, right? If I put 15, what's going to happen? Not a darn thing. Let me ask you this. What if I just, I don't know, let's say t equals -2 to 2. What did I not specify here? Spacing. Could you guess what MATLAB does internally? Let's try it. So the default spacing is 1 unless I specifically declare it, and then I can use the colon to go from my lower and my upper. If I want to turn from a, I don't know, a row vector to a column vector, I use the transpose operator, right? Okay. Here's a challenge for you. Please tell me how to use linspace. So there's this really special thing, linspace. I'd like you to create this vector. So I'm going to do the, let's do -2 to 7. So I want you to create that vector using the function linspace. So I'll write it out for you. And then, I don't know, should we use the commenting on YouTube? And Kyle, when you get this answer, please wait 2 minutes, because I don't want to have to pay you overtime. Same thing with Josh. All right? And yes, James, you taught me MATLAB this morning. I hope every one of you teaches me MATLAB by the end of the quarter. And I hope you realize that no teacher ever.
I didn't teach you anything, but
You helped me learn some code this morning, right? Ah, look at you, James. I think Michelle's got it. Do you have it? Okay. So then here's my next question for you. I wonder if I could... so let me post this online. What is the relationship between MATLAB's... we're going to call this the... I don't even know what I called that darn thing. MQN, yeah. Darn it. T equals MQN notation. And the linspace function. Okay, so one thing that I'll say here is we have now seen this particular notation. We had this idea that I could do like M, Q, and N. Do you want to give some names to those when you use the colon? Could you guess what we might call M? Min value, the lower bound, right? Q? Yeah, say it again, Wesley. Try again. That was a beautiful guess. Let's correct it. So if I do this, MATLAB's going to complain. Why is MATLAB complaining? Yeah, so...
Declare the variables within the command.
Oh, yeah, sure. So let's do M equals 1, Q equals 2, and N equals 4. And then let's go ahead and just grab the last bit of code that MATLAB yelled at me about. So Wesley, you want to see something? Check it out, Wesley. So what does Q do in that notation? So if I go back up here, Adam, I think you have it, huh? Yeah, you might call it the delta, right? So if this was a Riemann integral, do you want to see if we can break MATLAB? Yeah? I always like breaking. What's going to happen right now? What did I do with that line of code? Do you see it? Okay, so I need a reminder because, to be honest with you, before I taught this class, I was working in Mathematica for about 2 years. I want to know how to kill a command. That's bad language, especially given this. Yeah, do you see what I just did? This is going to go on forever. So what I'd like to do is be able to stop this command from running so that I can exit into the command prompt. It's not bad, right? So here's the challenge for you. Please figure out how I can stop a command from running. And you can use Google. That's legit. And in this case, this is a race because I actually want to stop this now. Control. You see that? She just taught me MATLAB. So I ran a bit of code that my computer was not really designed to function well on, right? And James did the calculation. He counted, what's the spacing there? So again, let's go back to Wesley. If I think about this thing, let me not run it again. wait, let me do this for a second. Q equals 1. That's a little better, right? When I run this, Wesley, what does M stand for? This one right here. Lower bound. What does Q stand for? Delta. In Math 1B, what was delta again? Lower bound, upper bound minus divided by n minus 1. Is that the same thing as Q here? In this notation, do I take Q is equal to n minus m divided by n minus 1?
Well, not n. It would be a different n.
Here's another way. Is Q cognizant of the values of m and n? What is Q in code? Who controls Q? The coder, right? And then the actual output, so if I said like 2, 4, and 3, what's that code going to produce? Let's try it out. Tell me about that. Natalie, can I ask you? So we have this this line, so the colon, the whole idea of the colon is that I'm going to create a... No? Okay. Okay, can we talk a little bit? No, okay. Maybe at break we can check in. So we're going to create a row vector, right? The lower bound of the row vector is 2. The upper bound of the row vector is 3. And then I'm telling it I want the spacing to be 4. So MATLAB starts at 2, adds 4, checks, is 2 plus 4 less than upper bound? Is 2 plus 4 less than 3? No. So in that situation, what do we say? End operation, right? What would I need to put for my upper bound to get a second entry of that row vector? Say it again. Or but not. Okay. So we're going to call this the MQN notation. You can also call it the colon notation. Can you guess why I might call it colon notation? because I rely on colons, right? Here's a challenge for you. What is the connection between the colon notation and the linspace notation? So in particular, let's go ahead and try to do this same vector, linspace 2, 10. Uh-oh. What just happened? Say it again. Yeah, so here we go. So if I say t equals linspace, let's do the size of t, 1 by 100. So linspace, what does linspace do? What type of vector does it create? Row vector. If I don't specify the number of entries of that row vector, how many entries does it give me? 100. So let's specify the number of entries, shall we?
Why does it prioritize the upper bound?
That's a question for the coders at MATLAB, right?
Because if you do the same thing in space,
Yeah, so what you just said is if I said 2, 12, 10, the colon notation prioritizes the lower bound, but the linspace notation prioritizes the upper bound, brought to us by a small scientific experiment just testing the material, right? So now the next question for you is, what does the third argument of linspace do? Okay, so yeah, say it again. The number of entries, right? The third argument of linspace tells me the number of entries that I want. What then is the delta between my entries? How do you know that? Yeah, good. Because otherwise you have to do that out of your own head, right?
Yeah.
So the what she just said is that the delta is the second entry minus the first entry divided by, yeah, so in other words, Q is going to be equal to, this one's kind of interesting, M minus N divided by, I mean, it's not even, it doesn't even work out that way, right?
well, we wouldn't want to use n. We'd want to make a new variable for our third
Yep.
linspace.
Yeah. I mean, I think I actually gave that to you in your notes, right? Let me ask you this. Could you, let's do this one. Let's do 60, negative 5 to 0. Could you get that same vector using linspace without looking at the notes? Hey, Jessica. I see you in person, and I also see you in, what's that called? Avatar. Okay. We've got our first guess online by the man that is neither a fool nor a matrix. Okay, so that one didn't work.
I think copy pasting stuff.
I could just retype linspace there. What was the third argument of linspace? The number of entries. So let's go back up to here. And let's just call this thing test. And let's do size of test. So now, watch this. Let's do answer minus test. When I see answer minus test, what do I see immediately? Okay, check this out. If I take the norm of answer minus test, oh, I have a different answer now, right? So let's go back to this. Let's take the norm. Let's go ahead and do linspace of 13 minus the vector that I wanted. Could you guess what the norm does? What does the norm do in Math 1C, the magnitude? When I take the magnitude of a vector, what does it tell me? Geometrically, it's supposed to tell me the magnitude, the absolute value of a vector. The length of the vector. What's the only vector under the sun that has length 0? The 0 vector. What does that test immediately tell me about those two vectors? Why? Okay, so these are two different vectors, or excuse me, two different lines of code, right? One of them produces a row vector that is 1 by 13. The other one produces a row vector that is 1 by 13. Could you guess what happens when I subtract those? Well, let's just go ahead and do this. Let's create a vector, I don't know, 1 to 12. And let's create another vector that is 1 by 12. Could you guess what the function ones does? We'll take a break in just a moment. Yeah, so I could literally take, it creates a vector of all ones, right? Okay, so let's take a look at our first vector. What is this vector right there? A row vector with how many entries? 12 columns, each of which value, first entry is, second entry is 2, 3. So let me ask you this. What would happen when I subtract one from the other? I decrement every single entry by 1. So what does that then mean? If I subtract two vectors, I take the norm of those two vectors, and I get 0. Every entry subtracted every other entry ends up producing 0, and then I take the square root of the sum of the squares of each entry. Again, Math 1C should be a prerequisite. I get 0. It must mean that the first vector that I had is identical to the second vector that I have, right? Okay. I think this is a good place for a stop, and then we'll come back at break time and chat through, after break time, we'll chat through the idea of processing matrices.